Okay, what we're going to be trying is to show you how to do some of these problems like on page 179 using what we have learned about trig functions and whatnot. Now you can see I have a circle drawn with the point at 2, 6, and I'm going to go ahead and show you how I can take that point 2, 6 and drop a right triangle that's going to look like that. So if I have that right triangle drop, the adjacent side, the side that's next to the angle, is 2. This is 6. Of course, that's because this is the point 2, 6, and the adjacent side is always the x-coordinate in a coordinate plane. The opposite side is always the y-coordinate. And then if I need to find the length of that hypotenuse, which you notice is also the radius of the circle, I could say that 2 squared plus 6 squared equals r squared. Simplify, that means 40 is r squared. So r would be square root of 40, which would simplify to 2 square root 10, because the square root of 40 is 4 times 10, and the square root of 4 is 2, so 2 root 10. So if I'm looking for all of my trig functions, let's go ahead and start with them over here. My sine of my angle is 6 over 2. I'm sorry, that's incorrect. The sine of the angle would be 6 over 2 root 10. And if I rationalize and reduce, that would be a 3 root 10 over 10. Now the trig, well, over 10, don't need a root 10 on the bottom. It's 3 root 10 over 10. Then on the next one, the one that goes with sine is cosecant. The one with an S goes with the one with a C. So cosecant, I would just flip that upside down. So that would have been a root 10 on top and a 3 on the bottom. Okay, when I go for cosine, cosine of theta is adjacent over hypotenuse. So that's 2 over 2 root 10, which reduces and rationalizes to just a root 10 over 10. Once again, the one with the S is the opposite of the C, so the opposite of cosine is secant. So flip that upside down, would have left you with just a root 10 after your 2's cancel. We'll go over here to have some room to write tangent and cotangent. Tangent is the opposite over adjacent, which in a coordinate plane is going to be the y-coordinate over the x-coordinate. So 6 over 2 reduces to 3. And then cotangent is 2 over 6, which is 1/3. Hopefully this is a good review of what we did a couple days ago with finding trig functions from a point. Now we're going to look at number 2 would work the same way, except for I would have some negative numbers. And when I use my negative numbers, my sine and my cosine would have both been negative answers. The negatives would have canceled out for tangent and cotangent, and you would have had positive answers for those. But we won't take the time to do it today. We're going to go on to number 3. Okay, for number 3, you can see I have reduced the size of my circle a little bit, but let's go ahead and see what it would look like. It is a negative 90-degree angle, so that would be 0. Negative is going in this direction, so that would be a negative 90-degree angle would be about right there. Now, the reason I bring this up is because this is actually exactly like what we were doing when we were evaluating from a point, but we have to use the angle to get the point. On the last one, I could have used the point to get the angle. On this one, I'll use the angle to get the point. Here's what I mean. If I'm going down 90 degrees, notice that the point on my circle I have is right here. Now, how you label this is kind of up to you, but it's simplest to label this and just decide whatever my radius is going to be 1. So if I pretend that that radius is 1, it doesn't matter if it's 3 inches or 7 inches or 14 millimeters. You can just say that, hey, I'm saying it's a radius of 1 something. You basically make up a measure and say it's 1 radius till I get to that point. Now here's the key to that. If I make up that radius and assume the radius is 1, that point there would be the point 0, negative 1. So of course my x-coordinate is 0 and my y-coordinate is -1. So now when I get ready to do my trig functions, my sine is always my y-coordinate in a coordinate plane. So the sine of 90 degrees, we'll go ahead and use 90 degrees instead of a theta, I guess, since they gave us that. The sine of -90 degrees is going to be -1 over 1, because my radius is 1, my x-coordinate is 0, and my y-coordinate is -1. So -1 over 1, because sine, once again, is y over r. We just reviewing what we talked about a couple days ago. So when we look at the next one, the opposite sign is cosecant. And I would just flip that upside down. So instead of having -1 over 1, technically I would have 1 over -1, but it's really the same answer of -1. The next pair, I can look at cosine. Cosine of -90 degrees is going to be my x-coordinate 0 over my radius of 1. So cosine is going to be 0. But secant, when I flip that upside down, I would end up with a 0 in the denominator. So if I tried to do 1 divided by 0, I cannot do that. Secant would be undefined. Last but not least, my tangent is the y-coordinate over the x-coordinate. So tangent of -90 degrees is -1 over 0, which is undefined. And then cotangent, I would flip it upside down. So instead of having -1 over 0, I'd have 0 over -1, which is 0. And once again, like we mentioned the other day, if you have one value that is 0, its reciprocal is undefined. If one value is undefined, the reciprocal is 0. That always relationship will hold for any of your trig functions. And since I'm going straight down, that is why the sign is negative, because anything going in the negative direction on the y-axis would be a negative sign in cosecant. Let's go ahead and look at number 4 as